Okay, so the next question that we got on the menu is asking us exactly this. A crate of mass 32 kilograms is riding on the bed of a truck attached by a cord, looking like this. And that truck is driving fast. There's no friction, so we gotta find the maximum acceleration that the truck can have before the cord breaks. And the maximum amount of tension in the cord is going to be 68 newtons. As soon as we get to 68 newtons, that one cord is going to turn into two cords that are not as long as they are originally. That's what's going to happen once we reach 68 newtons. So let's draw a free body diagram for this situation. Okay, so suppose we have a truck. This can be like the back of the truck. There's our wheel holes. This can be like a dude driving. And then we have our mass here, 32 kilogram. Okay, and we're gonna have a cable here. So the max that this can have is 68 Newton. And are there any other forces that are in this system? Yes, yes there are. So we know that, assuming this is on Earth, we're going to have a gravity force, Fg, and the back of the truck is going to have an opposing force, the normal force. And they will perfectly cancel each other out because the net force will be zero vertically. Vertically, the net force is zero, and because, well, we know that there's no vertical acceleration, we're only accelerating horizontally as the truck accelerates. Okay, so because there's no friction, when this truck slides, or when this truck starts to drive, this mass doesn't know that it's moving. Like, it doesn't know that it's moving until the cord starts pulling on it. But since there's no friction, I don't know if you ever tried this. Like, if you ever had a wagon with something on it, and then you pull the wagon real fast, and the thing on it slides off. Or if you ever seen those magicians who put things on a tablecloth and they pull away the tablecloth and the stuff stays there. That's essentially what would happen here if the truck just started to accelerate, because there's no friction. Okay, so we know that F equals ma. The only unbalanced force that would cause the mass to move, because it's connected via the cable, is Fc. So let's call that F cable. Fc for F cable, the force of the cable. And the force of the cable has a maximum force in it of 68, because once it gets past the 68, well, it's a split. That mass is sliding off, probably going to hit someone on the highway. Not a great thing. So Fc is equal to mass times acceleration. The only mass that is involved in here is the mass that's given there, the 32 kilograms. So, and we're trying to solve for the maximum acceleration. So A equals Fc over m. And Fc, well, that should be the maximum, because we're trying to find what is the maximum acceleration that we're not allowed to pass. So the moment that it hits 68 newtons, we'll have 68 newtons with a mass of 32 kilogram. The acceleration at that time is going to be 68 divided by 22. Pull out the handy calculator. 68 divide 32. 2.125 meters per second squared. So meters per second squared. So if the truck is suddenly going at like 2.5 meters per second squared acceleration, well, that cable is going to be like, yo, chill out, bro, chill out. That is too far. I'm actually going to brake. If you had more than that for acceleration, it's going to brake, and the thing's going to slide off the truck, and probably get you in trouble. Okay, so we know that the maximum acceleration, we don't pass 2.125. If you pass that, you're going to have some car insurance stuff to deal with, and that's not going to be great. Okay, so yeah. And then we use the Newton's second law, just like them. And 2.1, well, yeah, sounds about right. I guess you could, since the question gave us everything with 2 significant figures, we should round that to 2 sig figs. 2 SF, 2 significant figures, not San Francisco, but San Francisco's a nice place. This would just be 2.1 meters per second squared. Okay, just for significant figure adjustments. Cool. And yeah, the above solution is good.